The Cold War, a decades-long rivalry between the two most powerful nations in the world, both racing to outdo the other in an arms race. With the Soviet Union close on its tail technologically and militarily, the United States needed a way to keep tabs on what the Soviets were up to, especially when it came to nuclear weapons. The U-2, the predecessor to the SR-71, was a reconnaissance plane used to capture images of Soviet missile sites and other important areas from above, with much success. However, on May 1, 1960, a U-2 was shot down over Soviet territory. The pilot was captured, and the US's spying operation was uncovered. It was a big problem. Soviet missile systems were getting better, and the skies were no longer safe. The US needed something that was faster and could fly higher, something the Soviets couldn't shoot down. That's where Lockheed Martin's Skunk Works division came in. They were a top-secret team of engineers known for building futuristic aircraft that pushed the limits of contemporary engineering. The SR-71 had a few stages in its development, originally classified as Project Archangel, then designated as the A-12 by the CIA, before it finally became the SR-71. The leading force behind the SR-71 was Clarence Kelly Johnson, the head of Skunk Works. Kelly also helped develop the P-38 Lightning and U-2 spy plane. Despite having one of the most knowledgeable aerospace engineers in the world, building the SR-71 was nothing short of a miracle.
The design that they proposed to the CIA could fly at Mach 3.2 with a service ceiling above 85,000 feet. A modern-day airliner flies around Mach 0.8 from 30 to 42,000 feet in altitude. This plane was developed in the 1960s without modern technology. The SR-71 had to overcome many engineering and logistical challenges. To start, at Mach 3, the surface of the aircraft got so hot from friction and air resistance that regular materials like aluminum physically couldn't withstand the heat. So the shell for the Blackbird was 93% titanium, which could withstand heat of over 300 degrees Celsius at Mach 3 flight. However, the US didn't have enough titanium to build all of the Blackbirds, and the world's biggest supplier of titanium was the Soviet Union. So, ironically, using many shell companies and intermediaries, the CIA had to buy titanium from the Soviets to build a spy plane to spy on the Soviets. Another challenge was working with the titanium. It was difficult to work with. The engineers had to invent new tools, new welding techniques, and even new ways to fuel and cool the engines. The Pratt & Whitney J58 was specifically designed for the SR-71. This engine used hybrid technology to turn from a primarily turbojet engine into a ramjet mid-flight. While approaching Mach 2, the engine acts like a turbojet, sending incoming air through a compressor and burning it with the fuel. However, it works differently above higher speeds. At speeds greater than Mach 2.2, compressed air is sent straight to the afterburner, maximizing the fuel's efficiency and increasing the acceleration of the plane. A special fuel had to be developed with specific requirements. It had to withstand high temperatures caused by friction and air resistance while cruising at Mach 3, have low volatility, a high flash point, and high thermal stability. It was actually so stable that it was used as a coolant before being incinerated.
When thinking of the Blackbird, there are two important dates that come to mind. On December 22, 1964, the SR-71 Blackbird had its first flight. Pilot Robert J. Bob Gilliland was informed that there were 379 potential problems with the aircraft, yet still stepped in and flew it. Despite the potentially unsafe state of the aircraft, Bob managed to achieve supersonic speeds and flew up to 45,000 feet on its very first flight. The second date was July 28, 1976. The SR-71 broke two official world records. It set the record for the fastest air-breathing manned aircraft at 3,529.6 kilometers an hour. It also set the world record for the highest sustained horizontal flight at 25,929 meters. Even though the SR-71 was officially retired in 1998, its legacy lives on. The SR-71 brought to attention the benefits of steel plating for high-speed flights. It was one of the first aircrafts to make use of radar-absorbing materials, contributing to its stealth. Its success inspired Skunk Works to expand upon their stealth planes, leading the way for the F-117 Nighthawk, F-22 Raptor, and the F-35 Lightning II. And the SR-71 itself, it was never shot down. In over 30 years of missions, no enemy weapon ever caught it.